All right, now for our last lesson in this mole unit, and it is on empirical formulas and also molecular formulas. So first, we have to talk about what is an empirical formula. So there are two types, molecular and empirical. The molecular formula is exactly how many atoms of each element are in a molecule. So for example, hydrogen peroxide, H2O2, that's its molecular formula. The empirical formula is the reduced formula, kind of like how you would reduce fractions. So for example, benzene is C6H6, but its empirical formula is CH. Acetylene is C2H2, and its empirical formula is also CH. So even though they have different molecular formulas, these things have the same empirical formulas. And sometimes formulas can't be reduced, like rust is rust. Fe2O3 is Fe2O3. There's no way to reduce it. And so what we're going to do is, when you're trying to, this comes from what we do in real labs in college, is you're given an unknown substance and you need to figure out what it is. And one of the things you do is you take part of your sample and you send it off to be tested. And they will give you back the relative amount or percents of each element in your molecule. And so we can use those to figure out the formula. So what we're going to do, if we're given percent, we're going to assume 100 total grams so that we can convert the percents to grams. Basically, that's just for me to say it. You just, when you see a percent sign for these types of problems, just turn it into grams and move on. Okay? Then we're going to convert them into moles, which we then convert into whole numbers, which we then use to find the formula. Okay? So we're going to start with the grams and percents, convert those to moles. Then we're going to take those mole numbers and we're going to make them into whole numbers. And then we're going to use those whole numbers to find the formula. All right? So that's kind of the path that we're going to go on. Mathematically, this looks a lot uglier than it really is. Okay. All right, so let's look at an example. What is the formula of a compound that has these percents? So we've got sodium, carbon, hydrogen, and oxygen. We're given percents of each. So first thing we got to do is turn those percents into grams. And then we're going to convert those to moles. Okay? So doing basic mole conversions here. Grams to moles until we convert all of them to moles using molar masses to convert them. All right? So this is just good old practice for your doing mole conversions. All right, so we get these numbers. Now, I can't use these numbers to write my formula. I can't say Na1.22, C2.44. Like, I can't do that because it doesn't work. And so we don't have, our formula is always written in terms of whole numbers. So we need to convert these into whole numbers somehow. And the way you're going to do that is you find the smallest one, which in this case is 1.22. And we're going to divide by it. In this case, it's pretty obvious to see that that happens. And so we divide everybody by 1.22. And that converts everybody into whole numbers. 1 mole sodium, 2 moles carbon, 3 moles of hydrogen, and 2 moles of oxygen. We then use that to figure out our final formula. NaC2H3O2, sodium acetate. Okay, so that works pretty simply. All right, let's look at another example. Find the empirical formula given these grams. You got chromium, you got oxygen. So once again, convert those grams to moles, and then we're going to convert them into whole numbers. So we get these values. Smallest one is 0.323. So I'm going to divide by that. But I run into a problem. 1.5 is not a whole number. And I can't divide by the smallest one again because the smallest one is 1. So, yeah, I need to do something about this. So when you have this happen, so when you get a decimal after trying to get the whole number, you need to multiply to get rid of the decimal. In this case, 0.5, just multiply it by 2. And I need to multiply both of them by 2. So this one times 2 and this one by 2, which turns this into a 2, this into a 3, and my formula is Cr2O3. Okay. This will happen when you don't have any, when your lowest part of your formula doesn't have a 1 in it, like it's got a 2 or a 3 or something like that. You'll have to multiply it. This will happen, you'll see halves like this that you multiply by 2, and then sometimes, but less common, you'll see like 1.33 or 1.67, and those you multiply by 3 to make them into whole numbers. Okay, so that's doing empirical formulas. It's not hard, it just looks messy, and it's a bunch of mole conversions. So you do all your mole conversions, divide by the smallest one to get whole numbers, and then that gives you your formula. So now we need to add, we can actually, if we have enough information, we can determine not only the empirical formula, but we can also determine the molecular formula. So if we're given the molecular weight, then we can actually figure out the actual molecular formula. So this is what we're going to do, we can find the molar mass of the empirical formula. This is what I call the empirical weight. You'll never see that written in any book that I've seen. I call it the empirical weight because we're going to combine it, we're going to relate it to the molecular weight. So the ratio between the two weights will give us the ratio between the two formulas. That makes sense. If something is 5 times heavier, then the formula should be 5 times bigger. Okay, so it works pretty simple. So whatever that ratio is the ratio I'm going to use to find the formula. And I'm just going to do a really quick example here without having to go through all the other things. So normally I would give you the percent and you'd have to figure out the empirical formula first. But I'm just going to give you the empirical formula now just to make it simple. So I've got an empirical formula of CH2O, and I'm told the molecular weight is 180 grams. So I figure out my empirical weight using the periodic table again, using molar masses, and it's 30 grams per mole. The ratio of molecular weight to empirical weight then is 6. 180 over 30 is 6. So since the weight of 180 is 6 times bigger, my formula is going to be 6 times bigger. So multiply everything by 6, C6H12O6. And that's to doing empirical formulas. All right. So hopefully this will give you more practice with your mole conversions so that you're super comfortable with those before we move into the stoichiometry unit, which is next. And so once again, if you have any questions, work in the workbook, check the key, ask in the Facebook group, email me, come to office hours, whatever you need to do to help you learn this. We are here to support you.